Closures must be one of the most terrifying features in JavaScript. If you ask ChatGPT, what is the most complicated thing in JavaScript? Closures will be in the top 3. So today, let's make them simple. We will start with a very typical closures in React problem in the form of a small mystery to make things interesting. Dive deep into what closures are and how they work in native JavaScript. Discover what the stale closure problem is, where this problem typically occurs in React and how to fix it with normal tools, and learn a little trick that can help us escape the stale closures with refs. And as a result, we'll solve the mystery, of course. Let's start. Imagine you implementing a form, a simple input field with your customer name and a very heavy component underneath, maybe an address plugin with the map built in. That thing will have a button, and on click on that button, you want to submit your input data. Fortunately, that heavy component gives you an on-click callback. So from the code perspective, the task is very easy. You would have your form, your input component, some state that holds the value from the input, and that heavy component that accepts title and on-click callback. And of course, the callback itself, just a function that grabs the state and sends it to the backend. But unfortunately, we will have a performance problem here. We change state on every keystroke. The entire component re-renders because of it, and heavy component re-renders as a result. And that thing is really heavy. Because of that, typing in that input field is just painfully slow. So you decide to fix it. The obvious choice would be to wrap that heavy component in React.memo. But for React.memo to work, we also need to memoize all its non-primitive props. But wrapping on-click in use callback will be no use here. It will depend on the state, unfortunately, since we need to send that stuff to the backend. So with every state update, the on-click will be recreated, and the heavy component will behave like it's not wrapped in React.memo. Instead, we can try to go fancy and try memo's comparison function. This comparison function is the second argument of React.memo. It should return true if the props are the same, and re-renders will be stopped. So we compare the title prop there. Don't include on-click in the comparison, so it doesn't return false all the time. And here you go. I type in the field and heavy component doesn't re-render anymore. Except for one tiny problem. When I type something and then click that button that submits the data, the value that I'm trying to send is undefined. If you see something like this in real life for the first time, you might go crazy. Look at the code. No linting, no TypeScript screaming at you, nothing is obviously broken, and the worst thing that I can expect from the look at it is just memoization not working properly, since onClick is not wrapped in use callback. The last thing I would expect here is for the value to just disappear inside onClick. This is a classic example of what is known as the stale closure problem. We'll take a look step by step at what exactly is happening here a bit later. Because in order to do that, we need to first understand what closures are and how they work without React. Let's start with the beginning. What happens when we create a function in JavaScript? By doing so, we create what is known as a local scope. Variables declared inside won't be visible from the outside. Every function does that, even if it's nested inside other functions. In the opposite direction, however, it's an open road. The innermost function will see everything that is declared outside. This is achieved by creating what is known as a closure. The function inside closes over all the data from the outside. It's essentially a snapshot of all outside data frozen in time stored separately in memory. If I pass that outside value as an argument, return that inside function, and then call the parent function with a few different arguments, we'll get this behavior. We call our function with the value first and assign the result to a variable. The result is a reference to a function declared inside. A closure is formed. From now on, as long as the first variable that holds that reference exists, the value named first that we pass to it is frozen, and the inside function will have access to it. The same story with the second call. We pass a different value, a closure is formed, and the function returned will forever have access to that variable. This is true for any variable declared locally inside the function. If I create a random value, that value will be different in both functions. In React, we're creating closures all the time without even realizing it. Every single callback function, functions that we pass to hooks, or return from hooks, all of them are closures with their own copy of props, state, and local variables. But all of the above, although slightly unusual if you're coming from a language that doesn't have closures, is still relatively straightforward. You create a few functions a few times, and it becomes natural. It's even unnecessary to understand the concept of closure, to write apps in React for years. So what is the problem then? Why closures are one of the most terrifying things in JavaScript and a source of pain for so many developers? It's because closures live for as long as a reference to the function that caused them exists. And the reference to a function is just a value that can be assigned to anything. For example, what will happen if I cache that inside function that is recreated on every parent function call and assign it to a variable? On the surface, the code seems harmless. We just created an external variable named cache and assigned our inside function to the cache.current property when the parent function is called for the first time. Now, instead of this inside function being recreated every time we call the outside function, we just return the already saved value. However, if we try to call it a few times, we'll see a weird thing. No matter how many times we call the parent function with different arguments, the logged value is always the first one. We just created what is known as the stale closure. When we first called the function, we created a closure that has the string first as an argument. Then we saved it in an object that sits outside of the parent function. When we called that function the second time, we already had the value stored in cache, so we just return it. And the third and all other times. But that value is a closure from the very first run. It had the string first frozen in time. As a result, all those calls will log the very first value, the one stored in cache. To fix this, we would want to recreate the function and its closure every time the value changes. We can, for example, cache that value as well, compare it with the one passed as an argument, and if it's different, recreate the function. Now, if we pass the same argument a few times, then the returned function will be cached and the internal function won't be recreated. But if I pass a different value, the internal function will be updated and the correct value from the correct closure will be logged. In React, it's quite easy to create a stale closure by accident. Every function that we pass to anything that preserves values between re-renders can potentially create a stale closure. The most obvious example here is, of course, memoization. Use memo and use callback hooks. In our typical component, as I mentioned, every function is a closure. If I wrap that function in use callback hook with no dependencies, this closure becomes stale. It's frozen at the time the component was mounted. That is the entire purpose of use callback hook. If I try to access state in that function like this, the logged value will always be undefined. This is the reason we always have to add dependencies to our memorization hooks. If the value in the dependencies changes, the closure will be recreated with the updated value. It's almost exactly the same logic as we implemented in the caching example before. And of course, exactly the same behavior will be for any hook with the dependencies array, like useEffect. Second, a little bit less known example of creating stale closures by mistake is useRef. This will be a very typical example of that, initializing a ref with a function. This function is a closure. Every function inside the component is. The useRef hook is initialized only once, when the component is mounted. That function will not be updated on re-render. The closure becomes stale, and the value that is logged will always be undefined. In order to fix it, we need to explicitly recreate our closure with the latest state data. But the useRef hook doesn't have dependencies array for that. Instead, we can manually mutate the ref value inside our useEffect hook. This one has dependencies, so don't forget to add our state there. By doing this, we are making sure that inside our ref, we always have the latest closure on every re-render. And the final one, our mystery from the very beginning, the React memo and its comparison function. Let's take a look at the mysterious code again. We have the heavy component that is wrapped in React.memo with the comparison function that returns true if the title property hasn't changed, and a component with some state and the onClick function that we pass to that memoized heavy component and where our console log always prints undefined. The fact that we have the onClick callback on that heavy component implies that it has something like a button to which this onClick is attached. Let's assume it looks like this. Just a button with onClick that is coming from props. The full code looks like this. And we already know that the stale closure is the problem here. But let's walk through the code anyway to make sure we know exactly how it happens. Step 1. What happens here when a component is mounted? We initialize a state with undefined value, and we create our onClick closure. That closure we pass as a prop to the heavy component, and this one passes it further to the underlying button. Now the interesting part. Let's change state. State update will trigger re-render of the entire component, so everything inside of it is erased. And we begin our new rendering cycle. State has changed, and our closure is recreated with the latest state value. But our title on the heavy component hasn't changed. Since this component is wrapped in React.memo, React will start comparing props, or in our case, it will trigger the comparison function instead. And since our title hasn't changed, the function will return true, and heavy component won't re-render, exactly how React.memo is supposed to behave. However, the fact that heavy component wasn't re-rendered means that nothing inside of it was updated, including the closures coming from props. what we have still attached to the button is the very first closure with the state undefined. This undefined will be logged when the button is clicked. It doesn't matter that we recreated it in the parent component. The button inside of the heavy component never received it. How to fix it now? Let's first get rid of the comparison function. It does us more harm than good here. Now that we are left with the normal React.memo, we need to make sure that all non-primitive props are memoized again. And again, we face exactly the same problem as in the very beginning. The onClick function depends on the state, so memoizing it won't help with our performance problems much. Heavy component will still re-render on every state update. There are a few things we could try here, of course, like playing with composition, getting rid of state completely, or just debouncing it. But today, I want to show you one very cool but lesser-known trick that helps us escape that closure trap completely, which actually takes full advantage of closures to solve the problem. We'll use refs for that. Let's first get rid of all the unnecessary code here and leave only the component and heavy component on the screen. Next step, let's add a ref and add our future onClick function to that ref. We're going to do that inside the use effect hook, which we should do with any refs anyway. And don't forget the dependencies array. We need to make sure that our closure that is assigned to the ref has the latest state. But we can't just pass that ref to the heavy component. It changes with every state, so it will be no different from wrapping that function in use callback. Instead, let's create a new onClick function that doesn't depend on state and that we will pass as a prop to the heavy component. No dependencies, the function is never recreated, and memoization will work as expected. The only tiny problem, of course, is this function doesn't do anything. Let's fix that. All that we need to do now is just to call the function that we attached to the ref.current inside our onClick. This is the mind-twisting part. Ref by itself is an object preserved between re-renders by React. Its reference never changes, so we don't have to add it to the dependencies array of use callback. However, we explicitly mutated that object's current property inside our use effect. Closures don't perform deep cloning of objects. When the closure is formed, the reference to the object is frozen. But the object itself is still mutable. So if something mutates it outside of the closure, this mutation will break the closure barrier. So when we call ref.current inside our stale closure in use callback, we are actually calling ref's mutated property, which is the latest closure with the latest state. Now we have the best of two worlds. Memoized component, all of its props are memoized and never change, but the onClick callback has access to the latest state. All code examples to play around with are linked in the description, along with the article on the same topic that has more detailed information and even more code examples. Hope the video was useful, you had fun and learned something new today. Until next time.